Aldol condensation. This is today's lesson. Aldol condensation is a kind of condensation reaction in organic chemistry that is followed by removal of water. Aldol condensation involves aldehydes, ketones, and alpha hydrogen. In this lesson, we are going to learn aldehydes, ketones, and alpha hydrogen, reaction definition and the word aldol, mechanism of aldol condensation, crossed or mixed aldol condensation, and finally formaldehyde, benzaldehyde, and 2,2-dimethyl-propanol. These compounds do not undergo aldol condensation. What is the reason behind this? So, let's go to the detail. First point is aldehydes, ketones, and alpha hydrogen. Let's see one by one. First of all, aldehydes. This is functional group of aldehyde. When this hand is satisfied with hydrogen or alkyl group or aryl group, then the compound formed will be aldehyde. Alkyl group is derived from alkane and aryl group is derived from aromatic hydrocarbon. Aryl group, for example, phenyl, naphthyl, etc. That is, one hand of aldehyde must be satisfied with hydrogen or alkyl group or aryl group. Then the compound formed will be aldehyde. Now let's see ketones. This is carbonyl group. When these two hands are satisfied with alkyl group or aryl group, this hand as well alkyl group or aryl group, then the compound formed will be ketone. That is, these two hands of carbonyl group must be satisfied with alkyl group or aryl group. Now let's see about alpha hydrogen. Let's write a compound CH3, CH2, COH. Here, this is aldehyde group. Carbon atoms in the carbon chain are numbered in two ways. One, by English digits, and in that case functional group carbon must be numbered by 1, then 2, then 3. But in another way the carbon atoms are numbered, that is by Greek letters, lowercase, and in this case the carbon atom which is linked to the functional group carbon, that carbon is mentioned by alpha and next carbon is beta. If there was next carbon, then it would be gamma. That is, the carbon which is linked up with functional group carbon, that carbon is mentioned by alpha, next carbon beta, and so on. So this carbon is alpha carbon, and the hydrogen atoms that are linked up with alpha carbon, those hydrogen atoms are called alpha hydrogen. Here 2 alpha hydrogen atoms. These 2 atoms are alpha hydrogen atoms. Let's see another compound CH3COH. This is functional group carbon. So the adjacent carbon is alpha carbon. The hydrogen atoms that are linked up with alpha carbon, those hydrogen atoms are called alpha hydrogen atoms. In this molecule there are 3 alpha hydrogen atoms. Let's write another compound, CH3, 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 COH. In this case, this carbon is alpha carbon because this carbon is linked up with functional group carbon. But in this carbon, there is no hydrogen atom. So here, no alpha hydrogen atom. Let's see another compound, formaldehyde. This is functional group carbon. Here no adjacent carbon. So in this compound no alpha carbon, so no alpha hydrogen. Let's see another compound. This is benzaldehyde. This carbon is functional group carbon and adjacent carbon is here, which is alpha carbon. In this carbon as well, there is no hydrogen atom. So in this compound, there is no alpha hydrogen. This is all about alpha hydrogen. Let's move on to the next point. Reaction, definition, and the word aldol. Let's write aldol condensation reaction that involves aldehydes, ketones, and alpha hydrogen. Let's write aldehyde. For example, acetaldehyde, CH3COH. Another molecule of acetaldehyde, CH3COH. Aldehyde is treated with dilute alkali, sodium hydroxide, and the reaction is carried out at 20 to 30 degrees Celsius temperature. Then in this molecule, electronegativity of oxygen is 3.5 and carbon is 2.5. So these pi bonded electrons move towards oxygen. As a result, it becomes negatively charged and carbon becomes positively charged. Here it becomes negatively charged, carbon becomes positively charged because of the higher electronegativity of oxygen. Because of this positive charge, these covalently bonded electrons move towards carbon, and as a result, this hydrogen is freed as proton that combines with this oxygen, and this carbon becomes negatively charged. This negatively charged carbon, that means now this compound is a nucleophile. So this nucleophile combines with this carbon. Now let's write the compound, that is CH3COH. COH. Then here this H, this carbon and this carbon form a new bond. See, here H2COH. This compound is formed. That is, this is alpha, this is beta. So this compound is beta hydroxyaldehyde. This is the reaction, aldol condensation that involves aldehyde. Now let's write reaction of ketone CH3 that is propanone or acetone, another propanone CH3COCH3, which is treated with dilute alkali sodium hydroxide, and the reaction is carried out at 20 to 30 degrees Celsius temperature. Then here it becomes negatively charged, it becomes positively charged. Because of this positive charge, these covalently bonded electrons come towards this oxygen. Then it becomes negatively charged, and this hydrogen is freed as proton. Here it becomes negatively charged, this carbon becomes positively charged. This proton combines with this oxygen and this nucleophile combines with this carbon. Then the product is CH3COH. Here this CH3, CH2CO, CH3. Here this is alpha carbon, this is beta carbon. This compound is beta hydroxy ketone. So these two reactions are aldol condensations. Let's see the definition of aldol condensation. Aldehydes or ketones having alpha hydrogen atoms undergo condensation by nucleophilic addition in presence of dilute sodium hydroxide, dilute alkali, to form beta hydroxyaldehyde or beta hydroxy ketone. This reaction is called aldol condensation. Aldehydes or ketones having alpha hydrogen undergo condensation through nucleophilic addition reaction to form beta hydroxyaldehyde or beta hydroxy ketone. This reaction is called aldol condensation. Now let's see about the word aldol. Here this is functional group of aldehyde and this is functional group of alcohol. From the word aldehyde, ALD, and from the word alcohol, OL is taken. Now the word is aldol, that is, this word came from this product which is produced from aldol condensation. Here the compound contains aldehyde group from which ALD is taken, and it contains alcohol as well. From this OL is taken. Now this is aldol. So this compound is aldol as well. Here in this case we get beta hydroxy ketone. Alpha hydrogen containing compound like acetone undergo similar aldol condensation reaction. That is why this reaction is called aldol condensation as well. Let's move on to the next point. Now the point is mechanism of aldol condensation. Let's see the mechanism. Step 1. Diluted sodium hydroxide is used here that produces hydroxide ion. Step 2. This hydroxide ion reacts with aldehyde. Here it becomes positively charged, it becomes negatively charged because of the electronegativity difference. So these covalently bonded electrons move here and hydrogen is freed as proton. This proton combines with this hydroxide ion to form water, and here CH2 minus charge COH, that is nucleophile. Carbanion nucleophile is formed. This carbanion nucleophile another aldehyde. Here it becomes negatively charged, it becomes positively charged. This carbanion nucleophile attacks this positively charged carbon and combines with this aldehyde. That is why it is said nucleophilic addition. Now the product is CH3, C, here minus charge, then here hydrogen, this hydrogen, then CH2, COH. This species is formed. Now this species reacts with water. From this water, this hydrogen is freed as proton. This proton combines with this oxygen. Now the compound is CH3, COH, here H, CH2, COH. So this is formed, which is beta hydroxyaldehyde, aldol condensation product. This is the mechanism through which beta hydroxyaldehyde is formed from aldehyde. This is aldol, beta hydroxyaldehyde. Let's move on to the next point. Now the point is crossed or mixed aldol condensation. That is aldol condensation that involves different kinds of aldehydes and ketones. Let's see one example. Aromatic aldehyde is taken, which can be written as in this way, and another one is aliphatic aldehyde, CH3, which is treated with dilute alkali at room temperature around 25 degrees Celsius. Then this hydrogen is freed as proton and combines with this oxygen. Now the product is OH, this carbon with H, this H, here CH2, OH, beta, this is alpha, this is beta, beta hydroxyaldehyde. It's a kind of cross or mixed aldol condensation. Let's see another example of crossed aldol condensation. Now benzaldehyde and ketone are taken. Benzaldehyde, CH3, CH3, ketone, acetone or propanone. The reaction is treated with diluted sodium hydroxide and it is carried out at around 25 degrees Celsius temperature. Then this hydrogen is freed as proton that combines with this oxygen. It becomes negatively charged, it becomes positively charged. This nucleophile is added to this carbonyl carbon. Then the product is OH, this OH, this carbon and this H. Here CH2, CH3, that is beta hydroxy ketone, which is the product of aldol condensation. This is crossed or mixed aldol condensation, because here different kinds of aldehydes and ketones are used. Benzaldehyde is a kind of aromatic aldehyde, and this ketone is a kind of aliphatic ketone. That is why this is called crossed or mixed aldol condensation. Let's see another example. Now, one is aldehyde, aliphatic aldehyde, another one is aliphatic ketone. Let's write CH3, H, here ketone CH3, CH3, which is treated with diluted sodium hydroxide and carried out at around 25 degrees Celsius temperature. Then this hydrogen is freed as proton that combines with this oxygen. Then we get CH3, CH, here OH, here this is CH2, O, CH3, that is beta hydroxy ketone. This is hydroxyl group, beta hydroxy ketone. This is formed from aliphatic aldehydes, two different kinds of aliphatic aldehydes. There is a chance to form another product, that is when this is written first like CH3, CH3, here CH3, that is here H, this one. Then this hydrogen is freed as proton and combines with this oxygen. Then the product is CH3, here COH, and with this carbon CH3, here CH2, this one. So this is beta hydroxy ketone, this is beta hydroxy aldehyde. So same reaction, but there is a chance to form two kinds of products. One is beta hydroxy aldehyde and another one is beta hydroxy ketone. Actually both the compounds are formed, but which one is major product and which one is minor product? Let's see. In case of ketone, CH3, this can be written as CH2, here H, O, CH3. This bond becomes polarized, minus, plus. This positive charge, because of this positive charge, these electrons come here and this hydrogen is freed as proton. But this positive charge is decreased because of this methyl group, which is electron donating group. That is why this positive charge density is decreased, and as a result this hydrogen is freed as proton but laboriously. But in case of aldehyde CH3, this is H, but here this is methyl group. Oxygen becomes negatively charged, carbon becomes positively charged. Because of this positive charge, these covalently bonded electrons move here and this hydrogen is freed as proton. Here positive charge density is not decreased like this ketone. So in case of aldehyde, only hydrogen is present, no alkyl group is present. That is why no electron donor group is present here. So this hydrogen is freed as proton, which is easily. But in this case, this charge is decreased. That is why this hydrogen is freed as proton, but not easily. This is laboriously. Because of this product, that is beta hydroxyaldehyde. Beta hydroxyaldehyde is the major product, which is more than 50%, and beta hydroxyketone, because of this alkyl group, electron donor group, it becomes less than 50%. So in this crossed or mixed aldol condensation, beta hydroxyaldehyde is the major product and beta hydroxyketone is the minor product. Now the point is, formaldehyde, benzaldehyde and 2,2-dimethyl propanol. These compounds do not undergo aldol condensation. Let's see the reason behind this. In this compound, there is no alpha carbon, so there is no alpha hydrogen, and as no alpha hydrogen, this compound doesn't undergo aldol condensation. Here this is alpha carbon, but in this carbon there is no hydrogen. As no alpha hydrogen, this compound doesn't undergo aldol condensation. This is another compound. This is alpha carbon, but in this alpha carbon, no alpha hydrogen. As this compound doesn't contain any alpha hydrogen, this compound doesn't undergo aldol condensation. So the compounds that do not have alpha hydrogen are not capable to undergo aldol condensation. This is all about aldol condensation. No more today. Thank you very much.